Okay, so there's the graph. So that was kind of step 3. Go to your y equals, type in the function. Remember, we need to do 1 over the function. Okay? And then we got to view the graph, transfer key points, and then and the asymptotes. I want you to draw the asymptotes in. And then we just kind of finish and complete it. Make it smooth and continuous. Okay? So key points. Remember, we kind of set up our scale marks to match this very well. Okay, so at my first tick mark, or pi over 4, I have a coordinate at -3. If you want to hit trace to see that, you could. You're just going to get decimals, but I guess if you just want to see your y value, you could. All right, but it should be pretty obvious because of the way we set it up. So pi over 4 is at -3. I kind of boxed that in too soon. Sorry about that. So I've got this coordinate here. What's my next key point? Pi over 2. There's an asymptote right here. I want you to draw in. Okay, next key point is 3 pi over 4. I'm up at 1, 2, +3. Draw that in there. And then it ends, you got to remember the pattern. Every pi radians, there's another asymptote. Okay? All right. Okay, and then we just kind of fit those little U-shaped graphs. Run it along this asymptote on through. I'm not too worried about any other key points in between here. Don't worry about it. Just fit that U-shape the best you can with the asymptotes and the turning point, and I'd be happy. Okay. All right, and then that's one period, and then it just repeats itself. It's going to do the same thing over here. Okay, so if I go back, you can use your calculator to verify because we set it up for this. At negative pi over 2, okay, I have an asymptote, and then at negative pi, I've got the other asymptote. And that's the +3, that's the -3. So this one is the +3, asymptote. Okay, -3, asymptote. Okay, and get rid of this box. I've kind of boxed it in just for, calculator purposes. Okay, let me just take you through one more, and then I'll have you guys try 3 and 4 and wrap this up. Here we go. Period for secant is the same as its reciprocal, cosine. Maybe we want to get this out of the way right now. Let's think about how the relationship with cosine, or how we'd punch this in the calculator. There is no number out front, so if there is, we'd have to do this like we did in the last problem. This one doesn't. So we can kind of just jump right to that reciprocal setup of 1 over cosine of x minus pi over 2. Okay. So the period is going to be 2 pi over b, and b is just 1. So the period remains 2 pi for this one, which makes the scale marker tick marks 2 pi over 4, which is going to be pi over 2. All right, setting this up on paper is key, because then remember, our window and our calculator should reciprocate that. So this is pi over 2. This is pi, 3 pi over 2, and 2 pi. Okay. And then backtrack it as well. Negative pi, negative 2 pi. Okay, so once we got this foundation, now we're ready. The y scale, I don't know. There's no number out front, so we probably don't have to go as high as -6 and 6, but that should be fine. But this is key, so that now I can set my x min. Right, this is my x min now. I could write, there we go. And then 2 pi will be our x max. All right, and then this is our x scale. Okay, just trying to give you the computer talk or calculator talk here. All right, so go to window, change it to negative 2 pi now, to positive 2 pi, scale of pi over 2. I'm going to keep my y-axis the same, but you can adjust that a little bit as needed. And then we got to remember to change our function rule. Right now, I still have the -3 cosecant in there. We got to tell it this function rule. Okay, so y equals, clear what we have in there, 1 divided by cosine this time, x minus pi over 2. Okay. And now we're ready to graph. Okay, and remember the parent function for secant did start at the y-axis, but we actually had a phase shift going on. All right, so it picked it up and moved it right pi over 2 units. Those rules transfer over. But in the end, I just want you to transfer these key points. So it looks like there's an asymptote along the y-axis again. Then the next key point is at positive 1 at pi over 2. And then there's back to another asymptote at pi. So asymptote here, turning point at 1. And then we saw another key point at 3 pi over 2 at negative 1, and then an asymptote at 2 pi. Okay. And we don't cross these graphs over the asymptote, just run it right along the asymptote. Arrows to show that it keeps going. Okay, so there's one period, and then it's just going to repeat itself as we see over here, down to negative 1, asymptote, positive 1, asymptote. So negative 1. Okay, let's try 3 right now. We'll see if we need 4. I think we might be able to get by right now with 3. And this one just has a vertical shift. Just changes these coordinates a little bit, just shifts them up. That's all. Your asymptotes are the same. Just these turning points just shift up. All right. So anyways, why don't you pause, try number 3. I'll give you some feedback on that to start. Okay. Okay. So our period is 2. Making our tick marks. 2 divided by 4, or 1/2. So remember, this is critical. Don't even pick up your calculator till you figure out how you should set this up. Because now, if you don't set up your window correctly, your key points won't be correct. So negative 2 to 2. All right, it's exactly how I want to set this up. Scale of 0.5. I actually shorten this a little bit from negative 3 to 3. You don't have to, but the only time it starts at a higher number is when you have that multiplier out front. If there's no number out front, these turning points are going to be at 1 and negative 1, so I just kept it at negative 3 to 3. Okay, so let's punch in the function now. Here it is, 1 over sine pi x. And we're ready. Hit the graph, transfer these key points to get our final result. I'm going to pause while I'm transferring it. Okay, it's always a good idea to label your y-axis to some extent too, so I know what point this is. Don't forget to label that as well. Okay. All right, let's stop there for now. That was long enough. I'll give you some follow-up problems to work on for the week, okay?